Alright, good morning everybody. Alright, here in the woodworking shop again, getting ready to do some electrical for the smoke detectors. We're going to rough those in. Lights are already roughed in, we'll show you that in a minute. We're getting ready to basically insulate everything here. So next step is to get the electrical done, so then we can start putting in our fiberglass insulation, put up our vapor barrier, and then we're ready for our sealing material. So before we do that, it's kind of noisy out here because of the rain. I'm going to be moving around a lot. It's going to be power tools. So I was going to go ahead and give you a rundown on what we got going on here, what we're doing, and then you won't have to try to hear what I'm saying during the use of the power tools, etc. So what you're looking at here is a 100 amp sub panel. This one's made by Square D. It's called their Homeline series. It's a pretty popular panel. Square D is one of the more common brands. We're feeding this with a 50 amp 2-pole breaker out of the main panel. So we're actually feeding this 50 amps, 120, 240 volts. You will notice that down here we have a white wire, a red wire, black wire, and we have a bare ground wire. And you'll notice over here in the corner there's a bare ground bus bar, and then you'll notice the white wire is hooked to this bus bar. You'll also notice there's a jumper across the top that connects this bus bar to this bus bar. So what's happening here is, because this is the sub panel, National Electrical Code here in the US requires that we only have one bond between our AC neutral and ground anywhere in the electrical system. And that's typically done at your main service or your first electrical service panel, wherever that may be. In our case, we have a meter socket with disconnect, so we've made that bond there. Everything downstream is considered a sub panel, and we keep those two isolated. The general theory is you don't want a ground wire carrying current under normal conditions. The ground wire is only supposed to be fault current. So if you have too many bonds, you can alter that path, you can cause circulating currents. Interesting things happen. One thing I will point out is, in these panels right up here, typically there's a green screw that comes with this panel. It's usually not installed, and that would go right here and bond the panel to the neutral. So if this was your main panel, you'd put that screw in to make that bond. If you happen to get this panel and that screw's already in there and you're using it as a sub panel, that has to be removed. Another thing to point out is that this ground bus bar kit doesn't come with this panel. When you go buy a sub panel, and that's what this is because there's no main breaker, it does not come with that ground bus bar. You have to buy that separately. So don't run into your electrical supply house or your favorite big box store and buy a panel to go home and install it. Make sure you grab that ground bus bar. Just be there. These little stabs in the middle are where your breakers go in. Those are where the 120 volts are. You'll notice there's a bar on the left and a bar on the right. That's 120 and 120, and together you get 240 between them, or 120 to neutral on either one of them. So when you do a 2-pole breaker like this, it grabs 2 of them, and that's what gives you 240 volts for, like the table saw in our case. You'll notice that every other one comes off the opposite side. So when you put a 2-pole breaker in like this, you get the 240 volts. This breaker just snaps in. You see, I can pull it out. It's got little prongs that go on those tabs, and it's got a couple little sockets right here. So you basically would lock that in there against those, and you would roll that breaker into place like that. Now this panel is live. Absolutely shut your power off before you do this. If you're not comfortable, call an electrician. This doesn't really make me nervous. I work in it live, so do as I say, not as I do, I guess. We will have to pick up another breaker for the smoke detectors. Because we're not actually hooking them up today, we're just roughing them in. It's going to be fine. So our plan is to put a Romex connector in the top, drill a hole in the wall, and feed the wire up into the attic for the smoke detectors. We're going to mount our octagon box that we'll show you in a minute. And then we're going to come out of that octagon box, go through the wall into the automotive shop, which is the next bay over, so that if there is ever an issue in either one of these bays, it sets off all those smoke detectors in the building, hopefully alerting us as a problem in time to do something about it, but if not, at least to get out of the building, right? So without any further ado, I'm going to get you set up somewhere where you can see everything. We're going to go ahead and do this complete rough in. I'll fast forward through steps that you don't need to watch the whole process of. And then we're going to come back, hopefully, and get the shop insulated. We're going to get the ceiling insulated so it's quieter in here and you can hear what I'm saying. So hold on a minute. We're going to get you set up and we'll get this done. Alright, so we've ran the wire. You watched us mount the box, struggle to get the wire up through the wall, and we've got the wire into the auto shop, which I'll show you in a little bit. Now we're going to go ahead and connect the neutral and the ground in here, and we're going to leave the black coiled up. We will not be using the red, so we will cut that off. The red is only used between the smoke detectors. Between the power source and the first smoke detector, we just need the black and the white and the bare wire for the ground. Now, I like to strip my wires back with a regular utility knife. Caution, warning, be careful. We don't want to damage the insulation on the conductors. I'll show you that insulation in a minute. I tend to just be very cautious like that and get started. And just gently ride it down a little bit. I only do a few inches. I then take it like that. And I'm being very careful, not to get into anything else. And then I can just slide the insulation jacket right off as a complete assembly. You want to get rid of this cardboard paper that they wrap the ground in. And you also want to be careful because this ground is bare. So you want to be careful as it's flopping around in this panel that you don't touch something. Again, as I mentioned, I would highly recommend shutting the power off. Do as I say, not as I do, I guess. And one of the things I'll talk about while I'm doing this is I really do like hardwired smoke detectors. I like the interconnect between them. There's a lot of new wireless smoke detectors that talk to each other after programming. They're nice for retrofit, and they're probably just fine for new construction. I'm just a fan of the old mechanical assembly. If you apply that voltage from one controller to the next, it's going to trip the other one to go off. Everything's going to go off. I have enough issues with wireless and Bluetooth and that kind of things. I'm not going to trust my life to it, if you will. So now what we're going to do is we're going to dress this across the panel. And we're going to connect it down here to the ground. I'm not sure how visible that is. I'll give you a tutorial, or not a tutorial. I'll give you a tour of this when I'm done. Kind of a hard spot to work right now. There's no light in the shop yet because the ceiling's not up. The panel's tucked away in a corner, so kind of not the best video making place. All right, so that takes care of that. Like I mentioned, we're just going to go ahead and get rid of the red wire altogether. I'm going to dress that up. We still have to tighten the Romex connector up. And these just want to be snug. I will show you what I'm working on here. Let me go grab it. Give me 1 second. So a Romex connector is, let's see if you can see it. Yeah, you guys can see it right there. Basically what you got is you got this nut that comes off, and this piece goes through the electrical panel. The nut goes on the other side. So the nut right there is what you're seeing right up there. This piece is what you're not seeing on the top of the panel, and that clamps down on the wire by tightening up those screws. So you basically want to snug this down to the point where the wire doesn't move freely. You don't want to crank it right down with your impact because it will cut into the insulation of the wire, can short your wire out. You'll have nuisance tripping your breakers or possible fire. So that is what a Romex connector is. They make some plastic snap-in ones that don't have screws. Again, I'm sort of old school. I really like the old mechanical stuff. That's what I use. So now we're going to address the white wire, which is your neutral to the smoke detectors. And we're just going to tuck that right up in there. I'm going to come down. I like to make a loop about the size of my hand, like that, right there. And the reason I do that is in case we ever have to move anything or change anything, we have a little extra wire. I know it's not as nice looking, and I know the panel gets a little more crowded when you do that. But boy, if you've ever had to retrofit a panel or move some breakers around, and you don't have that extra inch or two of wire, you know exactly what I'm talking about. So we're going to tighten that neutral down. And as I mentioned earlier, we don't actually have our breaker, so we're just going to tuck the black wire right in the panel for now. And then we're going to get our screws out, and we're going to go get our cover, and we're going to install our cover so nobody sticks their fingers in there. So I'm going to show you what I did with the ground. See if I can get you out of the camera. So right in here is the ground bus bar that we talked about earlier. So I ran the ground up and around the corner of the panel and over and into my wire. So let me set you back down. We're going to go get the cover. We'll be right back. Alright, we're back with our cover. We've actually gone ahead and knocked out the proper knockouts for the breakers that we have in there now, which is our general outlets and our 240 volts for the table saw. We're going to be doing a lot more wiring in here over the winter. We're basically just trying to get it to the point right now where we can put a little heat in here. We're actually thinking a do-it-yourself mini split install. We're unsure of the brand we're going to use, so if anybody's got any suggestions what they like for the northern climates, put it down in the comments. These screws, the first time they go in, they cut their own threads. These panels are not threaded. So the first time they go in a little dry. Okay, the cover is on. We're going to go ahead and latch it shut. And you saw me change the bit in the screwdriver. I know I fast forwarded through that, but if you're going to do any amount of electrical work, one of these multi-tipped screwdrivers can be bought at any hardware store. What you're really looking at, let's see if I can get in there and show you. It's pretty hard to see, but that's a square drive bit. Very small square drive bit. All your screws and your cover, your breakers, your neutral bus bars, your ground bus bars, they all have that square tip socket. And that's a lot easier than a regular, bladed screwdriver. It doesn't slip out. That's why you saw me change partway through. I got frustrated with the regular screwdriver. So now we're going to go through just a real quick recap. Show you what we did. Like I said, we basically ran into the wall right there, and we went up into the attic, and we came across to our box right there, which is mounted down 3/4 of an inch because we're going to be using 3/4 inch cedar V-match on the ceiling. And electrical code basically tells us that if we're using a flammable surface on the wall, the box has to be flush with the surface. If we're using a non-flammable surface like drywall, I believe it's 1/8 of an inch. Don't quote me on it. But you're allowed the box to be recessed just a very little bit. So essentially what you're shooting for is the face of that box wants to be flush with the surface of the material that you're putting on the wall. And that's going to be nicer too when you go to mount your device, because the device is going to set flush and tight. It's not going to move around. If you've ever been in a house where you go to plug something into a receptacle, the receptacle moves all around. Generally speaking, that's because the box isn't out flush. It's not sandwiched in tight. They tighten the screws up to get the receptacle up to the same depth as the drywall, but it's not up against anything, so it's all loose and it moves around. So that's just good practice. Like I said, the wire is out in the automotive shop. We will actually continue from there into the residence at some point. We may do a video on that later. Thanks for watching, guys. Any questions about the electrical or anything, I'll do my best. I am a licensed electrician, but I haven't really practiced in the residential field in quite a while. I specialize in renewable energy, off-grid solar type stuff. So anyhow, check us out, leave your comments, and come on back and watch us put the insulation in the ceiling.